Am I on? Hey, okay. Okay. I'll say ahead of time, next week will not be as tedious as this week, so just bear with me. We're going to cover a lot of material tonight. I hope. Okay. There we go. Last week, real quickly, we covered the question of faith. What is faith? And we're interested in what is biblical faith. By that's what we mean. And what does God accept as saving faith? What does God consider faith to be? We found out that the secular definition is basically that what I would term blind faith. It's a belief or the affirmation of certain types of statements that one must accept independent of any logical proof or material evidence. So, blind faith, accepting without reason. And what I want you to remember from that lesson is biblical faith is not blind faith. The Lord commands us to use our minds in the execution of our Christianity. We're to love the Lord our God with all our heart, with all our soul, and with all our mind. And it's hard to understand how God could make us with minds that are so capable and demand that we use those minds in loving Him, and yet demand that we come to Him and to get faith totally absent of any reason. And we find that's really not the case. Did I skip something? We looked at several things. We looked at a number of examples of biblical faith from the Bible that are considered acceptable by God. The faith of Abraham, the father of the Hebrew nation. The Bible calls him the man of faith. And yet we find that Abraham was given a basis for that faith. And in Hebrews chapter 11, you know, the Hall of Fame of the faithful, it says Abraham, when he was told to offer up Isaac, reasoned that God could raise the dead. He had had experiences with God so that he trusted Him. And if God said the nation would come out of Isaac, it was going to come out of him somehow, and he reasoned that God could raise Isaac from the dead if He needed to. We looked at Moses, the lawgiver. We looked at Gideon. We looked at the nation of Israel as they wandered around in the wilderness. All of these had a basis for trusting God. When Christ came, He did all these miracles, and we looked at several of those. And virtually all the miracles of Christ are done so that people could accept Him as the Messiah, particularly His apostles and those disciples close to Him. The people that were converted on the day of Pentecost, again, Peter tells them to remember the miracles and the signs that were done among you that you yourself know that proved Jesus was the Messiah for them. And so on it goes. In virtually every case, the great men of faith in the Bible were given a basis for that faith, a reason to trust God. So we come up with this definition of biblical faith. It requires belief, sure. We academically have to understand that there is a God and we have to believe in Him. But it goes beyond that. You remember James says, you believe? Great. The demons believe and shudder. And the demons aren't saved. So we conclude that just simple belief is not what God intends for us to have. Faith goes beyond belief. It necessarily involves trust. And trust requires action. If you don't have action associated with trust, then what do you really have? What does it mean to say, yes, I believe you can fly the airplane, and yes, I trust you, but no, I'm not going to get on the plane? You see, God demands that we get on the plane with Him. He wants us to trust Him. So biblical faith requires belief. It necessarily involves trust that's followed up with action, and the whole business is based on reason in every case we looked at. And so the question is then, well, let me finish this. We've got one more thing. So in conclusion, we came with faith and reason are not mutually exclusive, as some people think. That faith begins with reason. rooted in experience that satisfies our minds, and then goes beyond that. Goes beyond reason. So the question is, what kind of evidence did God give us? Well, we'll get into that, but the next thing I want to look at tonight is faith reasonable in our time? We live in a time when everything has a reason. Everything has to be measured. And every effect we see has a cause rooted in this natural physical universe of ours. Everything must have an explanation. And that which doesn't lend itself to a physical explanation simply doesn't exist. That's pretty much the way our society, our world looks at things today, especially if you go to Europe. Does faith make sense in this environment? Can it be defendable? And I want to look, in order to look at that, we're going to look tonight at what makes things reasonable for us. And when we say reasonable, a lot of times we say, well, it has to be logical. So I want to look for a few minutes at what logic is. I want to look at logic, what it is, and its limitations. First of all, logic is the study of methods of correct reasoning. So we want to do that. That's a necessary condition for something to seem reasonable to us, to use correct logic. But I think you'll see it's not sufficient. Logic establishes the correct relation between statements of fact, called propositions, that must be either true or false. Propositions, simply statements of fact. And the relationship, I have to be in the right place here to make this thing work, I guess. A group of propositions that we take as the given points, we assume them to be true, are called premises. And a group of premises arranged in such a way that they imply something about the correctness or the truth of another proposition, called a conclusion, is called a logical argument. Now, this is not the kind of argument you have with your sister or your brother or husband and wife. It's not a fight. This is simply a very systematic way of putting down facts and extrapolating those facts to other things in a logical, systematic way. So let's look at an example. And bear with me, this is going to get better, I promise. This is a syllogism. It's a type of logical argument, and it consists of three propositions, two premises that result in one conclusion. First premise, if A is equal to B. And I have an arithmetic example over to the right. We take 3 times 2. If 3 times 2 is equal to 2 plus 2 plus 2, that's basically a definition of multiplication. It's a shorthand for addition. All right, our second premise is, and if B is equal to C, or 2 plus 2 plus 2 is equal to 6. What then can we say about A and C? Well, they're both equal to B, aren't they? And therefore, they're equal to each other. So our conclusion is A is equal to C. Everybody with me? And I apologize if this insults your intelligence, but I want you to see the structure of the logical argument and therefore be able to see its weaknesses and its limitations. So if A is equal to B and B is equal to C, then it's proven absolutely. If those first two are true, then the conclusion is true. It's an absolute proof. And so we end up over on the right, 3 times 2 is equal to 6. Let's look at a word one that might be a little easier for you, less formula type. If all dogs are mammals, first premise. Second premise, and all mammals have lungs. What can we conclude about dogs and lungs? All dogs have lungs, right? So that's a syllogism. It's a type of logical argument. Now, here comes the problem. Let's change one word. All dogs are mammals. And then we're going to change the second premise. All mammals have wings. Now forget about if it's true or false for the minute. If all mammals have wings and all dogs are mammals, what do we conclude about dogs and wings? All dogs have wings. See, the arrangement is such that if the first two premises are correct, the conclusion has to be true. There's a problem, isn't there? You know that it's not correct, not true. How do you know that? You don't know it by logic. Huh? Evidence. Okay. So, if we change it to where some mammals have wings, that's a true statement, isn't it? Some do, bats. But now what can we say about dogs? Well, if we've never seen a dog and we're just going on the logic, we can't say anything about dogs. Our argument is completely destroyed now because we no longer have an absolute premise up there. Everybody with me so far? So what's the problem? The problem is our inability, in most cases, to determine absolute premises. See, there are very few things in life that we know that are absolute. Most things are not. And if you don't have an absolute, you can't use this kind of argument. So logic by itself does not make something reasonable. Everybody with me? You get the point? I made it very simple so that you can see the weakness of logic. It's a very powerful thing. But like everything else, it has its place and it has its weaknesses. And unless you have absolute premises, logic will not prove something absolutely. If you have absolute premises, then you can get an absolute conclusion. It's absolutely proven. But unless you have absolute statements of fact to begin with, you can't arrive at a conclusion. And the problem is our inability to get logical absolute premises. What do you do about that? Well, there are two types of logic. There's the type we were just talking about, which is called a deductive argument. And it proves its conclusion absolutely. Unfortunately, you only run into this kind of argument usually in mathematics. Hardly anywhere else. The other kind of logic is inductive reasoning or an inductive argument. And it states what is probable, what's probably true. Maybe highly probable, but not absolute. And examples of this is in our courts of law. What do we say if a man's accused of murder? He has to be proven what? Absolutely? No. What? Beyond a reasonable doubt. What would happen if we required all murderers, all robbers, to be proven absolutely guilty? Would we ever put anybody in jail? No. So he has to be proven, according to an inductive process, guilty beyond any reasonable doubt. So it's probable, not absolutely certain, but probable that he's guilty. Highly probable. In fact, we rely on this process enough that we're willing to take a man's life based on that. I just want you to see what we're dealing with here because this is going to come up in the course. This all has a reason behind it. Another place you see it is in science. Oh, you maybe think science is absolute. It's not. Science, although it's a very systematic process, is a form of inductive reasoning. It doesn't prove its conclusions absolutely. In science, we build models, and we test the models with data, and if the data fits, we say, well, that's a good model, and maybe it happens this way. And if it happens that way over and over and over and over and over and over without ever a single exception, we eventually convert it from a theory and say it's a law of nature. But even then, it's not absolute. For 100 years or so, we thought Newtonian physics was right. You know, the way your automobile behaves, it describes a baseball, the real world to us. But along came Albert Einstein, and he started to thinking about things that move at extremely fast speeds. And lo and behold, if two cars are coming together and both at 50 miles an hour, what's their closing speed? 100, right? But if two objects are coming together at the speed of light, what's their closing speed? It's still the speed of light. Something has to give. Well, what gives is time. You have time dilation. You know, science is not absolute. It's a logical, an inductive process that tells you what is probably true. It could happen this way. in almost everything in life. When you go down to buy an automobile, you don't take your next door neighbor, the mathematician, down to scratch out an equation and say, okay, this is the model you need. It's not proven absolutely, is it? You look at the cost, the mileage, the number of people it can carry, whether it's aesthetically nice to you or not, the color, the kind of tires and rims, all this stuff, and you put that all together and you decide, well, I like this model better than that model. That's an inductive process. What about when you choose a profession? Or kids when they go off to college? It's a difficult decision. There's no equation that tells you to go to Alabama or Auburn, or maybe Tennessee, heaven forbid. How do you make that decision? You look at all kinds of information and you go through an inductive logical process. You may not think about it, but that's what you're doing. Even when you pick your wife, everything we do, basically, is an inductive logical process. Every decision we make. And the reason I'm banging on this so hard is because this is the process we're going to use in looking at the evidence for God. We can't prove God absolutely. Nobody can. And nobody can disprove God absolutely. But we can go through the same process by which we make every other decision in life, and we can be just as sure of the existence of God as we are of the guilt of a murderer. Everybody with me? Okay, there are some logical fallacies, and I'm going to skip most of these in the interest of time. But I just want to take a little side trip here and point out some of the problems you run into. For example, and this is certainly not a complete list, it's just a few examples, and I'm only going to mention a couple of them. But the first one, argumentum ad hominem, is probably one of the best known logical fallacies. What happens in court when a lawyer can't disprove the testimony of the witness for the other side? What's the next thing he does? He attacks the witness, doesn't he? Oh, this guy's a drunk. He beats his wife every Saturday night. He abuses kids. He's a chronic liar. You can't believe him. What's he doing? Is he evaluating what the witness has said? No. What he's doing has absolutely nothing to do with what the testimony was. He's trying to poison the well. He's trying to plant seeds of doubt in the jury so that they will discard this man's testimony out of hand. It's an illogical process. By the way, I was shocked to find out a good friend of mine who's a lawyer never had to take a course in logic in law school at Alabama. I don't know if they do today or not. I was surprised. There's two forms of it. That's the abusive form. The one that's more appropriate to us is the circumstantial form. The President of the United States may want to, in the face of our present gasoline prices, want to develop a better energy policy for the country. So he'll ask a number of people to sit on a panel and come out with good ideas. And let's say one of these people is the CEO of Exxon Company. And you can see now people jump up and down and say, oh, this guy, you can't pick him. He's got a conflict of interest. Why, he's making money off of gasoline. He's the head of the gasoline company. I mean, and so they want you to discard anything he might suggest out of hand without listening to what he has to say. Well, sure, he may have a conflict of interest. And sure, we need to be skeptical. But unless we listen to what he says, we may miss something. The CEO of Exxon, you see, may be in a position to know a whole lot more about the gasoline market, gasoline reserves, the refining process, and the capacity of the refineries, and all these other things. And he may be able to construct a much better energy policy than you or I could. We should be skeptical at times. But if we reject his ideas before he even states them, we're guilty of a logical fallacy. Argumentum ad hominem circumstantial. I want to skip to the last one, which is one that's particularly important to this discussion. Petitio principii. Begging the question, or probably better known as a circular argument. I mention this because it's going to be very important down the stream. This is the form of this argument. You remember before we had two propositions and they together implied something about the conclusion. Well, here, the conclusion is assumed already in the premises. The conclusion will be one of the premises. And so in its simplest form, it's simply, if A is equal to B, then A is equal to B. Well, what kind of logic is that? What kind of argument is that? If I already am willing to accept the premise, A is equal to B, I don't need an argument to convince me of that, do I? And if I'm not convinced of it, no argument that a priori assumes that's going to convince me. So this is nonsense, very simply. But you'll be surprised how often you see it in life. Let's look at an example. A mother may say, obviously, my son is the best student in his class. Well, Mom, how do you know that? Because he's the most intelligent student in his class. Well, how do you know he's the most intelligent student in his class? Because he's the best student. See, it goes full circle. Well, how about something more important to us? This is a word I coined, anti-supernaturalism. And it means exactly what it sounds like. It's a circular argument used by atheists. And almost all atheistic arguments are guilty of this. It's a dogmatic belief that nothing supernatural can exist. And a person who is of this mindset will reject any evidence, no matter how good it might be otherwise, no matter how well established, he will reject it if it's going to prove the supernatural. And I've seen this personally. So let's look at the argument. It can be much more complicated than this, but boiled down to its essence, the argument goes something like this. God does not exist. Why? Well, there's no evidence of anything supernatural, no evidence of supernatural events. So you ask, well, what kind of evidence do you need? Well, the thing that would fit the bill would be something that is observable. We have to see it or detect it somehow, or it's not evidence to us, number one. And number two, it has to be impossible, right? Within this universe, within nature and its laws. It has to violate the laws of nature. It has to be what we would call a miracle. That's the kind of evidence we need. So you ask, well, is not the resurrection of Jesus Christ exactly the kind of evidence you're looking for? And what's the answer? Oh, that didn't occur. That would be supernatural. See, it's just like the mother and her son. It's a circular argument. And it's more prevalent than you would believe. Okay, back to the original question. What makes something reasonable to us? Well, obviously it's not logic. Something can be logical and still unconvincing. Logic is a necessary condition. We have to use good logic, but it's not sufficient. Take something else. When we talked about the dogs with wings, how did you know that that was wrong? Did you know it by logic? How do you know that dogs don't have wings? Has anybody ever seen one? So you've never experienced dogs with wings, have you? If you have, I want to talk to you afterwards. Okay, so if you think about it, and this may surprise you, but what makes something reasonable to us is much more a function of what we have experienced, and in the process of experiencing it, become comfortable with, than what we can actually logically prove or understand even. You believe that? Well, let me convince you. Let's look at some examples. And I'm going to pick some things that may stretch you a little bit, but like I say, we'll come back down to earth next week. Gravity. Can anybody in here tell me what gravity is? Everybody comfortable with gravity? Does anybody here worry about walking outside the doors and flying off into space? We don't. Did anybody here lay awake at night worrying about gravity letting go of them or not working tomorrow? Or we're all pretty comfortable with gravity, aren't we? What is it? Does anybody know? Well, don't feel bad. If you've had high school physics, you might say, well, it's a property of matter. All matter attracts all other matter. Okay? Well, that's what it does. If you've had a little more physics, you might say, well, you know, on Earth, everything is attracted, and on Earth, objects, if you drop them, they will accelerate at 32 feet per second for every second they fall. And that's true. It tells us a little more specifically what gravity does and how it affects things. But what is it? So we go out to UAH and we ask a professor in physics department, well, what is gravity? He says, well, you know, it's a weak force that falls out of the equations for the general theory of relativity. That's nice. Is that supposed to make me feel good about gravity? You know, what is it? Well, you know, we really haven't gotten past the basic thing. It's a property of matter. It's a given that we have to accept. Well, let me ask you, why does our Earth not fly off into space? You know, I brought something here. I brought a little show and tell. I brought a yo-yo. What happens if I let go of this yo-yo, the string? Everybody want a duck? Why does it go in a circle? Because it's held in place by the string, right? Why does the Earth go in a circle around the sun? Gravitational force of the sun. Do you believe that? Do you realize how far away the sun is? How far away? Exactly. How far is the sun away? How far is it from here to the sun? 93 million miles. How far is that? Anybody got a feel for how far 93 million miles is? Let me tell you. Let me give you a feel for 93 million miles. If we had a special highway to the sun, and we'll forget about thermal problems and vacuum and all that, and we had a special automobile that could have in-flight refueling, and had a potty on board, and you know you can get fed, so you never had to stop. Did you ever take your parents' car when you were young and go out and drag race? Don't answer. But I can tell you from experience that 100 miles an hour on a 2-lane Georgia road is very fast. So let's assume that this car can travel 100 miles an hour and leave Earth and never stop. Travel a steady 100 miles an hour. Okay? You're born the day it leaves. And so you take off and you're driving down this highway through space, straight to the sun, straight line, and you travel 100 miles an hour. Minutes go by, and hour after hour after hour, and day after day, and week after week, and months and months and months go by, and finally years and decades. How old do you think you would be when you got to the sun? 93 million miles, 100 miles an hour, constant. You'd be 106 years old when you got to the sun. At 100 miles an hour. That's how far 93 million miles is. That might help. Now I want to ask you, you say it's gravity. How reasonable is it? And you're out there and you don't see any strings or cables or bars or anything like that between the earth and the sun. How reasonable is it that that sun, that far away, is holding us in a circular path? Why do we think that's reasonable? Everybody believes that, don't you? Why do you believe it? Yeah, but you can be taught things you don't believe. Let me suggest that you believe that because ever since you were old enough to stand up and fall down and skin your knee, you've experienced the attraction of gravity. Haven't you? And it's always done the same thing. It's always pulled you down, never threw you up. By the way, let me ask you a question. Why is it that gravity, and you may think this is a little silly and simplistic, but why is it that gravity just attracts? It's a force field. And if we think about magnetic fields, they do both. You put a north and a south pole, they attract. If you put a south pole and a south pole, they repel. Electric fields do the same thing. They can attract or repel. Why is gravity just attract? Anybody know that? I'm telling you, we don't understand gravity. So we accept the fact that the sun can pull us and hold us in its orbit because we've experienced all of our lives over and over and over and over, without a single exception, the attraction of gravity. And as wild as that might be, that far away, and nothing visible, we accept that there's a force there holding us in place because of what we've experienced here in our locale. But when we ask about Jesus walking on the water on the Sea of Galilee, a lot of people have a problem with that have no problem with the sun pulling the earth. Why is that? Because we've never experienced any repulsion from gravity. It's always attracted. Right? So we accept the concept of gravity because we've experienced its effects all our lives. And we've gotten comfortable with it. We cozied up to that idea. But I submit that you don't understand it, or you're holding back, one or the other. How about electrons? Well, everybody knows about electrons, right? They're the little things that run through the wires, and they cause the lights to work, and they give us heat and various things. What's an electron? You know? It's a little teeny thing. It's attached to atoms. But you can do experiments. There are two kinds of experiments you can do. And in one experiment, the electrons behave exactly like a swarm of BBs, little particles. If you were to throw a bunch of BBs out, that's exactly what the electrons behave like. You can do another type of experiment in which they behave just like when you drop a rock in a pond and the ripples go out and make waves. They behave exactly like waves. Now, folks, waves and BBs are not the same things, are they? So what are electrons? Are they waves or are they particles? Well, science gets by that. They say, well, there's a wave-particle duality, and I'm supposed to feel good about that. But I don't understand it. I've never had it explained other than that. But I'm comfortable with electrons. They do their job. And they're reasonable to me that they're electrons. Never seen one. I don't think anybody else has seen one either. But they fit the model, and it's reasonable to us. And why is it? Because we experience the effect of them. How about nuclear energy, atomic energy? Does anybody here, I don't know if you've had modern physics or not, but there are things like, well, Einstein's equation, E equal mc squared. That says you can convert energy to mass and mass to energy. They're equivalent. Well, that's not what you learned early in school. You learned that, well, there's energy and there's mass. And mass has properties, gravity and stuff, and energy has properties. And now Einstein comes along and says, well, under certain conditions, they can go back and forth. And a little bit of mass can make a whole lot of energy. Well, are you comfortable with that? Well, TVA is. The Japanese are. Quantum jumps, you know, if I told you how electrons behave in their orbits, and I made an analogy to a car down here at the Huntsville Speedway going around the oval, and you sit there and you mash on the accelerator, the driver does, and he tries to accelerate, and he keeps mashing the accelerator down and down and down, and nothing happens. And he just keeps going a steady 20 miles an hour, and the pace people are passing him like crazy, and he keeps trying to go faster, and nothing's happening until he finally puts the pedal down enough that the car can go 60 miles an hour, and instantaneously he's going 60 miles an hour. And then he tries to slow down, and nothing happens, and nothing happens. He keeps letting on, nothing happens, and suddenly he gets back to where it would be going 20, and it goes to 20. It's impossible for the car to go anything but 20 miles an hour and 60 miles an hour and nothing in between. You say, well, that's not reasonable. It's not logical. Doesn't make sense. But that's exactly the way electrons behave in their shells in the atomic structure. It's called quantum jumps. They can't go continuously faster or slower like a baseball or an automobile. They can only have certain set energies. And they jump instantaneously from one to the other. Nothing in between. Well, all of these things are involved in electricity coming out of the plant down there at Browns Ferry. We accept that, don't we? We're comfortable with electricity, but we don't understand everything. Time dilation, I'm not going to go into that. Let's look at, how about beginnings and infinity? Anybody understand those two things? Beginnings sounds pretty easy, doesn't it? But what was before the beginning? You see, science has wrestled with that for a long time. How did something come out of nothing? That's a very difficult question. And if anybody here understands it, I want to hear it. But we talk about beginnings. What about infinity? Space extends out. Is there a boundary on space? Well, if so, what's on the other side of the boundary? And if there's another boundary out there, what's on the other side of that boundary? I mean, there's no end to it. It's like trying to pick the biggest number. I can always add one to it. We don't understand these things because we are finite beings. We live in a finite universe. And we don't understand beginnings. We live within time. And we don't understand infinity. And I would submit to you, we cannot, with our finite minds, understand God, although a lot of us try. Okay, let me read you this. All you people have a bad impression of scientists. Here's what one scientist says. What strange rationale makes some physicists accept the inconceivable electron, we just talked about, the wave-particle duality, as real while refusing to accept the reality of God on the ground that they cannot conceive Him? Nobody can conceive an electron. We just know it has certain properties, it fits certain models, but try to understand rationally that how something can be both a particle and a wave. You can't. And who said this? Werner von Braun. So, what's the point of all this? The point is gravity, beginnings, infinity, and God, we can only understand to the extent that we've had revelation or experience. We can only accept as reasonable to that point. At the most basic level, we have to simply accept things. And this is true not only in religion, but also in science. So don't ever feel apologetic that there are things about God that we just have to accept. Because the scientists do the same thing every day. If you ask enough questions about the electron, they won't be able to answer. If you ask enough questions about gravity, they won't be able to answer. It gets to a point where you simply have to have a beginning assumption called a property of matter, or whatever you want to call it. And so people want to look down their nose at faith. But believe me, there's a lot of faith in the scientific world. And that's the point of that. I don't want you to miss that. I want to illustrate our difficulty in conceiving of things with a little story. There's a book written back in 1884 by Edwin Abbott. And the name of it's Flatland. It calls it Flatland because the story is about a race of beings that live in a plane universe. Their universe has only two dimensions, two spatial dimensions. Our universe has three, right? We have depth, width, and height. And anything else you want to point out would be some combination of those three. There's only three spatial dimensions in our universe. In flatland, there are only two spatial dimensions. So here's flatland. There's north, south, east, and west, but there's no up or down. No concept of up and down. Just like we have no concept of a fourth spatial dimension. The inhabitants of flatland have different kind of shapes. And they have different numbers of sides. And the number of sides you have determines your intelligence and your status in life. So triangles are the working class. If they are isosceles triangles, meaning they have all three sides equal. And all people in flatland have equals. All sides are the same length, with the exception of soldiers and policemen who have a shorter base, so they're more pointed. Professional people are squares and pentagons and hexagons and other types of polygons, going up in status as they get more sides, until you get to the figure that has, in principle, an infinite number of sides, and that's the circle, and they're the great high priest of flatland. And ladies, don't throw anything. This was written in Elizabethan England, and it reflects the opinion of people about women back then, but the line, that's a woman. Okay, so in flatland, people live in five-sided houses. They have doors, and people can move around all over the place, within the plane, but never up or down. Okay. Now we have a problem. We recognize that these people in flatland have different shapes. I can tell the difference in the high priest and the mathematician over here on the left because I can see their shape. But why can I see the shape? Because I'm looking down on it. It's like when you look down on a table at a quarter, you can see that the quarter is circular. But what if we weren't looking down on flatland? What if our eye were in the plane of flatland? What would we see? You see a line. And they don't have colors in flatland, so they couldn't tell the difference like I've helped us out here. So how do they know whether they're addressing the garbage man or the high priest? It's a problem, you see. But they're smart people. What they do, the less intelligent members of society simply walk around and count sides till they get back to the start. But the more intelligent people, since most figures are regular, meaning all the sides are equal, different figures have characteristic angles. So you can walk up and you can feel one corner, and if you feel 60 degrees, they have to be calibrated to do this, take some sophistication and some education, but they can go up, the higher members of society, and feel one corner, and they can tell if it's 60 degrees, it's a triangle. If it's 90, it's a square. If it's 108, it's a pentagon, and so forth. So that's the way they tell who they are, who they're addressing. Now, there's a problem with women, again. If that's a soldier or a policeman on the left who's dangerous because of his point, think about a woman. You see, a line, in principle, has no real thickness. I've just put some thickness on there so we can see it. But from the side, a woman looks like the high priest. But when she turns on in, she becomes invisible. And you see, that's dangerous. The story tells us that many a husband has met his end because he backed into his wife and didn't see her. See? So, in order to solve this problem, they made a law, 2 laws actually, to protect males that say that a woman, whenever they're in public, first of all, they must always make their presence known by the continual drone of their peace noise. In other words, they have to talk incessantly. And secondly, they have to sway to and fro as they walk so that they are periodically visible to everybody around them. So this is what a woman looks like in flatland. Okay. All right. Now I hope you have some feel for what living in flatland is like. No third dimension, no up or down, only north, south, east, and west. No concept of a third dimension. So let's go to the story. The story is told by a square who is a mathematician. And one night His wife and his orphaned 3 stepsons are asleep, and it's late, and he's up studying geometry, plane geometry, of course, and he's happy with his flat existence. And he suddenly hears a voice, and he looks around the room, and he sees absolutely nothing. And he thinks, well, maybe my wife's in here, and she's just, pointed the wrong way, and I can't see her. So he calls his wife, and she doesn't answer, and he walks around in the room, and he doesn't see her, and it's not his wife. Wife's not there. And this voice keeps talking to him. And the voice tells him that he is a sphere from space land. And the square says, what do you mean, space land? And he says, it's a land of 3 dimensions. I'm here to tell you the gospel of the 3rd dimension. And the square says, what do you mean, 3rd dimension? Everybody knows there's 2 dimensions. Even a beginning student knows that all figures, are plane. It lie in the 2 dimensions of the plane. And the sphere says, no, there's a 3rd dimension. I'm speaking to you from the 3rd dimension. The sphere can't understand it, but we can, since we live in 3 dimensions. The sphere is simply above the square's house. He's not in the plane of flat land, so he's not in the flat universe, and therefore is invisible in the flat universe. But somehow he speaks to him, and the eye of the square is contained in flat land. He can't look up or down because up or down doesn't exist, so he doesn't see anything. Well, is there a biblical analogy? Has God ever talked to people and they didn't see him? If you go back to 1 Samuel, and Samuel's a little boy, and he heard somebody calling him. He went in and said, here am I, to Eli. And Eli says, I didn't call you, go to bed. And it happened a second time, and Eli tells him to go to bed. And finally, the 3rd time, Eli's a little slow, but he realizes God's calling Samuel. And he tells him to answer God, and he does, and so forth. But Samuel saw nothing, but he heard the voice, just like the square. So God was speaking to Samuel. I'm not suggesting from a 3rd dimension, but from something outside of our universe, our physical universe. Okay, so in order to try to convince the square of his existence in the 3rd dimension, the sphere descends into the plane of flatland. And think of this as you take a ball and you put it in the water and you push it down. If it sits right on the top of the water, it's a dot. As you push it down, what does it make in the water, in the plane of the water? It makes a circle, doesn't it? And the circle will grow as you push it down until it gets to the equator, and if you let it up, it gets shorter and becomes a point again. So that's exactly what happens, see? And then the sphere does something else for the square. He does something, I can't back up, can I? No. Okay. He does something impossible in flat land. He bounces up and down and changes his size. It would be like a man standing before you and suddenly becoming 9 feet tall and then going back to 5 feet tall. It's not possible within the confines of the square's universe. And the square can't understand this, but he's not convinced. He thinks it's a magician or something. So it goes on, but there are similar biblical events. The disciples, after the crucifixion, where did they go? They went to the upper room, and they were afraid of the Jews, so they locked the door, and they're all in there, and what happens? Christ appears. He did it twice. Just appeared to them. The room was locked. Exactly what the sphere does for the square, because he has access to another dimension. Well, that was kind of neat. Let's do it one more time. Okay. Finally, in frustration, after a very long discussion, and unable to make any progress with the square, he simply cannot imagine the 3rd dimension. Nobody in Flatland has ever heard of the 3rd dimension, never seen it. It can't be measured. It can't be known in any other way. It's like I'm sitting here and I'm telling you there's a 4th spatial dimension, and your first point would be, well, point it out to us. And within the confines of a 3-dimensional universe, I can't point to the 4th dimension. The square couldn't imagine it. So, in frustration, finally, the sphere pops the square out of flatland into spaceland. And a most remarkable journey starts for the square. As he rises above his house, at first he can look down into his house. And you know, before he could never see the shape of his house, remember? We could only see that because we looked down on it. When he looked at his house or another person, he saw a line, didn't he? And he had to go around and count the sides or feel the angle to tell what it was. He had to infer what the shape was. He could see it now from Spaceland. He could see the insides, the innards of his 3 grandsons. And as he got higher, he could see his neighbor and his family asleep. And as he got higher, he could look inside all the houses in his whole city. And as he got higher and higher, he could see all of Flatland, the whole extent. He could see into the deepest caverns and caves. Nothing was hidden from his view. What about God? Nothing's hidden from his sight, is it? Well, there's another thing. He looked around him, now he's in Spaceland, and he sees the beings in Spaceland. There are geometric figures too. And the interesting thing he noticed, although far more majestic than the beings in Flatland, they had similarities. There were beings that were similar to him, the cube. But it had another dimension, another aspect to it that he could have never imagined in Flatland. The sphere was more majestic by far than any of the great circles in Flatland. Well, what about the way God made us? Did he put something in us that we can't see? When he said he made us in his image, did he mean that God has 2 eyes and a nose and a mouth and 2 arms and 2 legs? I don't think so. He gave us a spirit, didn't he? And it says God's a spirit. But has anybody ever seen their spirit? You know, it's an interesting little book, I think. So, toward the end, it's the beginning of the 2nd millennium of their time. And I want to read you this real quickly. The sphere has the square in Spaceland, and he takes him over the capital city of Flatland. And he shows him a building down there, which the square says he recognized as the General Assembly Hall of the States of Flatland. And he says, here, the sphere says, here we descend. It was now the morning of the 1st hour of the 1st day of the 2000th year of our era. Acting as their wont and in strict accordance with precedent, the highest circles of the realm were meeting in solemn conclave, as they had met on the 1st hour of the 1st day of the year 1000, and also on the 1st hour of the 1st day of the year 0. The square is excited. He says, let me descend and explain the 3rd dimension to them. Permit me. And the sphere says, not yet. That time will come. Meantime, I must perform my mission. Stay thou there in thy place. And saying these words, he leapt with great dexterity into the sea, if I may call it that, of Flatland, right in the midst of the ring of counselors. I come, he cried, to proclaim that there is a land of 3 dimensions. I could see many of the younger counselors start back in manifest horror as the sphere's circular section widened before them. But on a sign from the presiding circle, who showed not the slightest alarm or surprise, 6 isosceles policemen of the lowest type from 6 different quarters rushed upon the sphere. We have him, they cried. No, yes, we still have him, still gone. He's going, he's gone. And so this is what happens. Now, did that ever happen in the Bible? How about when they tried to kill Jesus before it was his time? And the whole crowd drug him up to the cliff and was going to throw him off the cliff. And it says he walked out from among them. How do you do that? My lords, the president of the junior said to the junior circles, there's not the slightest need for surprise. The secret archives to which I alone have access tell me that a similar occurrence happened on the last 2 millennial commencements. You will, of course, say nothing of these trifles outside of the cabinet. And raising his voice, he now summoned the guards. "Arrest the policemen and gag them. You know your duty." After he had consigned to their fate the wretched policemen, ill-fated, unwilling witnesses of a state secret which they were not to be permitted to reveal, he again addressed the counselors. He says, "My lords, the business of the council being concluded, I have only to wish you a happy new year." Now, the sphere comes back, and he puts the square back into flatland, and the square simply can't contain himself. It's now a capital offense to discuss the third dimension in any way, to even mention it. But he can't be quiet about it, because he knows it's true, and he knows that the sphere and the cube are far more majestic than anything that they know. And he has to tell about this thing that's so beautiful and so obvious, although he can't explain it very well. And he's found out, and he's sent to a mental asylum for the rest of his life. And the story supposedly is written in the 7th year of his confinement. Okay. What's the problem the sphere had in flatland? He had to convince people in a flat, two-dimensional universe of his existence in a third dimension, didn't he? A dimension that they could in no way measure, detect, imagine, or anything else. For the square, that became sight. But what about God? Does God not have the same problem as the sphere, Doesn't he? With us? How to make known to mankind in a physical universe the reality of a spiritual realm which we cannot experience in any way and can't imagine. It's the same problem, isn't it? Whatever God does, as we said before, must be physically observable in order to be evident to us, and it must be miraculous in the sense that it violates the laws of nature. It must be impossible within the bounds of the physical universe and its governing laws. Those are the two conditions that the sign has to meet. So how are we going to test the biblical claims? I'm almost through. I'm over again. What are the claims? Well, I've listed a few of them here. There's one God. The Bible is His inspired word. Man Jesus was God incarnate, came to live among us as a human. All mankind has sinned and fallen away from God, and Jesus is the only way back to God. And the proof of Jesus' deity is His resurrection on the third day. Those are the claims that we're supposed to believe. Do you really believe that? I mean, you look around and you have no reinforcement for that in this world. None whatsoever. It's total nonsense if you just look at this world. Nobody's ever experienced anything to reinforce any of these in our lifetime or anywhere near us. So how are we going to build a case? It's not easy, maybe. God says the ultimate proof is the resurrection. Jesus said the Son of Man will be betrayed, they will condemn Him to death, He will be turned over to be crucified, and on the third day He'll be raised to life. That's the ultimate proof that Jesus was who He claimed to be, and if He's who He claimed to be, then God exists, and the Bible is His inspired word because Jesus used it. How can we just construct a reasonable test of these claims? All right, here's the way we're going to do it. We're going to use the resurrection, but how are we going to get past this? Okay. Their test of historicity. Have you ever thought about how they decide something's reliable when they find an old document? Say some writing of Plato, for example. How do you decide if that's the real writings of Plato? How do we decide if the New Testament documents are the real New Testament documents? How do we decide if they're reliable? Well, there's a certain set of questions they ask. For example, who was the author? How did he get his information? Was it written down immediately after the event, in this case the resurrection, or was it written down 100 years later or 200 years later? When was it recorded? What's the condition of this copy we have? Do we have the originals? All kind of questions like that. Then there's archaeological evidence. You know, archaeology doesn't tell complete stories, but whatever it tells us is more or less absolute. You know, if we have a debate about whether a certain man was governor of a certain province in the 1st century, and we find a statue with a date on it and his name there as the procreator, that pretty well settles it, doesn't it? And if the story we're looking at has the same information, it reinforces that story. So we'll use archaeological evidence, and we'll use secular historical evidence. What did the people who were historians living in the time of Christ say about it? And we'll use all of these to look at the historical accuracies of the Scriptures, of the New Testament. And when we're through, my claim is you'll no longer look at this as a mystical type of book. You'll look at it as the most accurate history book we have from ancient history. Once we've established that, then we'll take the historical facts from the New Testament and look at the logical implications of those facts. And those implications then will have something to say about the truth of the biblical claims. Did Jesus really, was he really resurrected? Was he really the Messiah? Was he really the Son of God? We'll also use fulfilled prophecy. We'll use we won't be able to do this in a complete different study, but the unity of the Bible, the Old and New Testaments. Old Testament written over some 1,500 years by people ranging from slaves to wise kings on 3 continents. And yet it's orchestrated. And the question is, who could have orchestrated it? It's a study all in itself. We won't have time to do that. And we'll also look at some scientific accuracy. And we'll begin that next week. We'll look at lessons from space, Genesis 1 and lessons from space. And I promised you it won't be this tedious. You can sit back next week and enjoy some nice pictures from the Hubble telescope. Well, thank you for coming. Sorry I ran over again. It's getting to be a habit.
Just a moment. I've got a couple announcements that I want to share with you. I'll take about 2 minutes or less. Nita Ackerberger had her surgery Monday morning. She is doing well. They did find cancer.